everybody, it's Miss Carter again, and we are going to do some flipped learning for division strategies since you guys don't have school on Monday, so this will give you a head start for next week. We are going to practice 3 division strategies today. We'll do the same problem for all 3, but I'm going to show you 3 different ways to get there. Now you're probably thinking that these are really big numbers. You probably have not divided numbers this large before. The first strategy we are going to work on is something we call the Rapunzel strategy, or the 7 strategy, or the hangman strategy. You may have a different name for it. A lot of you were at class at the beginning of the year when we went over this strategy. And we call it the Rapunzel or the hangman or the 7 because we draw something that looks like this. Inside of that little hook, we put our dividend, which is the big number we're dividing. So 1,294. And I'm having a little trouble writing this small on my iPad, so hang with me. And that is a comma, not a decimal point. And then we put our divisor, what we're dividing our dividend by, on the outside of the hook. So we're doing 1,294 divided by 11. Now to solve this, we are going to work with powers of 10. So over here on the side, I'm just going to put 11 times 1 equals 11. What about 11 times 10? 11 times 10 equals 110, right? Because 11 times 1 is 11, plus that one more 0 brings us to 110. And then let's do 11 times 100. 11 times 100 equals 1,100 because 11 times 1 equals 11, and then we have 2 zeros that we add on to the end. We don't need to go any higher than that because we're just trying to make it up to this number, our dividend. And if we did 11 times 1,000, we'd end up with 11,000, which is way too high. All right, so let's get as close to this number as we can. Looking at our powers of 10 over here, we see that 1,100 is as close to 1,294 as we can get. And to get to 1,100, we multiplied by by 100. So I'm just going to do that over here on the side. 11 times 100 is 1,100. Now we're going to subtract to see how much we have left. 4 minus 0 is 4. 9 minus 0 is 9. 2 minus 1 is 1. And then 1 minus 1 is 0. Now we're focused just on what is left, which is the 194. We're going to try to get as close to that as possible. So go back over to our powers of 10, and which one of those will get us as close to 194 as possible? It would be the 11 times 10. 11 times 10 equals 110. So again, we're going to subtract to see what we have left. 4 minus 0 is 4, 9 minus 1 is 8, and 1 minus 1 is 0. So we are left with 84. Now we go back to our powers of 10 to get as close to 84 as possible. We know 11 times 1 is 11, which is really low. But if we move up to 11 times 10, we go too high. We're at 110, and we need to stop at 84. So what we can do is now work on our 11s facts. If 11 times 1 equals 11, what can I multiply 11 by to get me close to 84 without going over? Do your 11s. 11 times 2 is 22. 11 times 3 is 33. 11 times 4 is 44. If you keep going, you'll find that the closest you get is 11 times 7, which equals 77. Because if you did 11 times 8, you would get 88, which is too high. Again, we subtract. 4 minus 7, we need to regroup. So we're going to take from the tens place and make that a 7, and then we'll change our ones place to a 14. 14 minus 7 equals 7. 7 minus 7 equals 0. So we have 7 left. Is there anything we can multiply 11 by to get to 7? There is not. I'm sorry, you guys probably hear my dogs making noise in the background. So that means that we have 7 left over. What is that called when we have something left over in a division problem? That's called our remainder. So to find our quotient, the answer to this problem, all we're going to do is add up our partial quotients right here. So 100 plus 10 equals 110. And then we do the 7. So plus 7 more equals 117. And then don't forget your remainder. We have a remainder of 7. So our quotient is 117, remainder 7. Again, this is called the Rapunzel strategy. That's what I call it. It could be the 7 strategy or the hangman strategy. But it lets you break these up into easier numbers and multiplication facts you're familiar with until you get a final answer. Let's look at a different strategy with this same problem. So again, we have 1,294 divided by 11. And I call this the box method. So there are 4 digits in my dividend, so I'm going to make a box that's divided into 4 different parts. And then we're just going to put a digit of the dividend in each box. So a 1, a 2, a 9, and a 4. You guys with me? And then I'm just going to put my divisor of 11 over here on the side so I don't forget it. Okay, what we're trying to figure out is how many times 11 can go into this 1. Can 11 go into 1? No, it goes in 0 times. 11, and you can draw a multiplication symbol up here in the corner if you want to. 11 times 0 equals 0. So I'm just going to take 0 away. 1 minus 0 equals 1. And then with this strategy, whatever you have left over, you bump over to the next box. So now instead of a 2 in that box, we have a 12. How many times can 11 go into 12 without going over? It can go in 1 time. 1 times 11 equals 11. So we're going to subtract. 12 minus 11 equals 1. And then we're going to bump that over to the next box. Now we have 19 in the next box. How many times can 11 go into 19 without going over? Again, just 1 time. 1 times 11 equals 11. So we're going to subtract, and we're left with 8. And then if we bump that 8 over, we have 84, which if you remember from our last strategy, that's where we ended up with, where we had to figure out how many times 11 could go into 84 without going over. And we figured out it was 7 times. 7 times 11 equals 77. When you subtract, you are left with 7. So here's your quotient now. Your quotient's at the top, and then your remainder's what's left over. So we still have 117, remainder 7. Pretty cool, huh? I learned this strategy this summer, and I was so excited. All right, so that's our second strategy, is the box strategy. We're going to do one more. And this is probably a strategy, if your parents help you with math at home, this is probably the strategy you use to divide. And when I was in school, this is how I was taught to divide. And it's called the standard algorithm. With the standard algorithm, we are going to figure out how many times this divisor, 11, can go into each digit. So it's exactly what we just did with the box method, except it looks a little different. So again, just like we did with the box method, how many times can 11 go into 1? It can go into 1 0 times. And you can draw the multiplication symbol in the corner again if you need to. 0 times 11 equals 0, so we're going to subtract. 1 minus 0 equals 1. And then instead of bumping that 1 over like we did in the box method, we are instead going to bring our 2 down. We still end up with 12, just like in the box method. It just looks a little different. Now we ask ourselves, how many times can 11 go into 12? It can go in 1 time. 1 times 11 equals 11. We subtract, and we get 1. Okay, so with the standard algorithm, you're always focusing on whatever number's on the bottom. Now we need to bring down our 9. So you bring down one digit at a time and ask yourself, how many times can 11 go into 19? And we figured out it can go into 19 one time. 1 times 11 equals 11. We subtract and we're left with 8. And then finally we bring down our 4. How many times can 11 go into 84? We've done this 3 times now. It can go in 7 times without going over. 7 times 11 is 77. When we subtract, we have 7 left over. So our quotient is going to be 117, remainder 7. That is the standard algorithm. Okay, so 3 different strategies. You have the Rapunzel, and we call it Rapunzel because it's like she's letting down her hair. That was the one that looked like a hook, like this. We had the box method, or the box strategy, where we had a box and we divided the number up by its digits. And then we had the standard algorithm. Okay, so after watching this video, you are going to take a quiz on what you watched. I want you to tell me what your favorite strategy was, and then you're going to use your strategy or a second strategy to check it to solve a division problem. So thanks for joining me, and we will see you in class on Wednesday. Bye, everybody.